All right, continuing from where we were yesterday with transversals, we're going to move on to dealing with parallel lines. So if lines are parallel, we mark it with a triangle, like so. So I'm going to tell you that this line is congruent, parallel to that line. You can shade it in or not, it's up to you. But we're just going to do that. If ever we have more than one set of lines, parallel lines, we use one triangle for one set and two triangles for the other one, just like we do with hash marks and so forth, and angle marks. So we're going to write in some values here. So let's say that this angle here, angle 2, is 130 degrees. And we're going to make this 50 degrees. And hopefully you're going to start seeing some patterns here. Obviously, we know that vertical angles are equal, so that's why 50 and 50 are the same, and 130 and 130. But if you notice also, 130 plus 50 makes 180. Those are supplementary, linear pairs. But where we're going today is going a little bit further. Sorry, there's a dead spot on the board there. Like so. And we're going to learn something new about parallel lines. But if you notice what happens here, it's kind of like an escalator. So if I have this angle here, is 130. The cool thing is, if the lines are parallel, look what we have there, 130. Same thing with this one here. If we have an angle here, and it just slides down the escalator, and boom, it matches. Okay? But if it's under the line, that's all right. This one's underneath. It's like doing one of those, I can't remember the name of them now, when you grab the rope and then you slide down. An eagle's nest, whatever they call it. There you go. Zip line. There's the word. So you just ride the zip line down. Same thing right here. We've got this angle. We're just going to ride the zip line down, and all the angles match up. It's really cool. So, if two lines are parallel, the angle pairs have these special relationships. So name a pair of alternate interior angles. So we're going to go back and look for alternate interior. Now remember, interior means in between the lines. So that's going to be 3, 4, 5, and 6. Alternate means opposite sides lines. That's 3 and 5, or 4 and 6. We're going to say both of them, okay? And we should say angles, 3 and 5, or angles, 4 and 6. Now, what did we just prove with the zip line and the escalator story? Let's see. You can see that 3 and 5 are equal, okay? 4 and 6 are equal. In fact, all the acute angles are the same, and all the obtuse angles are the same. So, equal, congruent. All right? Now, how about a pair of alternate exterior angles? Let's step back. Remember, exterior angles are on the outside, so we're talking about 1, 2, 7, and 8. So we're going to talk about 1 and 7, or 2 and 8. Angles 1 and 7, or angles 2 and 8. What's their relationship? Also equal or congruent. Now, what about corresponding angles? Let's look at that. Remember, corresponding angles are the one outside and one inside. Well, that's the zip line, the escalator. See, here's the inside, here's the outside. Inside, outside. Outside, inside. So notice, those are also equal. So for corresponding, we're going to say 4 and 8, 2 and 6. We're not going to write all of them. So angles 4 and 8, or angles 2 and 6. And it goes on. There's quite a few more of them. What's the relationship? also equal. Now, same side interior. Well, remember, interior, again, 3, 4, 5, 6. Same side is the one obtuse and the one acute. And the neat thing about this is, that would be 4 and 5, or 3 and 6. So angles 4 and 5, or angles 3 and 6. And they are supplementary. Now, they're not a linear pair because they're not side by side. But they are supplementary. They add up to 180 degrees. Now, this is extremely important. There's already exclamation points, but you might want to put stars. This is only if you got parallel lines. That's it. Only time. Okay, example 1. All lines look parallel are parallel. So we're just going to tell you, we tell you not to assume in geometry, but we're telling you. Not to mention, notice, we do have the red triangles there, so we're telling you they are parallel. State the angle pair name and relationship. So the number and the question mark. Well, we have one inside and one outside. That's corresponding angles. Remember, we can abbreviate it this way. Okay? Now, use a little bit of common sense. All these angles are paired up either acute or obtuse. These are both acute angles. So our answers are always going to be either congruent or supplementary. And these two are congruent. All right? How about the next one? Well, they're both on the inside of these lines. They are on opposite sides of the transversal, so that makes it alternate interior angles. And notice again, this one is obtuse. This one is obtuse. They are congruent. How about down here? Well, let's see what we have here. We have an obtuse angle here, and this is definitely an obtuse angle there, so we know they're going to be congruent. Now, what are they? Well, they are on opposite sides of the transversal and both exterior. So alternate exterior angles. And what do we have here on the same side and inside? Same side interior angles. And notice, if you look carefully, this one's a cute little angle, and this one's obtuse. So they are not going to be equal. So our only other choice is supplementary. Remember, those are our choices. They're either going to be equal or supplementary. Now, all lines here that look parallel are parallel. If you want to make sure you remember, you can just write little triangles here to remind yourself these are all parallel. Now, here's the thing. The escalator works on every line. So 2 is equal to 6, which is also equal to 10. 4 is equal to 8, which is equal to 12. Again, all acute angles are going to be the same, and all obtuse angles are going to be the same. So it says, angle 2 is 110. So let's go here and write 110. Now remember, it might be a good idea to use a pen, a pencil you can erase. Okay. So what's angle 6? Well, there's a few ways to look at that, but angle 2 is right here, and if this slides on down the escalator, angle 6 is equal. It's the same thing. Another way to look at it is 2 is obtuse, 6 is obtuse, all the obtuse are the same. So this is going to be 110 also. Now, what's the name for 2 and 6? One's inside, one's outside, so that's corresponding angles. And they're equal. Now, we need to erase here the 110, because now we're going to say angle 6 is 108. Oh, well, that's what we were just at, right? So there's 108. What's 12? Well, if you look at this line and this line, and this transversal, 6 and 12 are outside the green lines on opposite sides of the transversal. Therefore, they are alternate exterior angles. But another way to look at it is 12 is clearly obtuse, 6 is clearly obtuse, all of the obtuse ones are the same, so 108 equal. Now we're going to erase again. Okay, maybe we won't. Or it's being difficult. Okay, angle 9 is 81. So 81 right here. What about angle 7? Well, that's right here. This is right here. They are both interior angles, opposite sides of the transversal, so they are alternate interior angles, which means they are equal. Sorry, alternate interior angles, let's go down here. And since they're equal, this is 81 degrees. And a couple more. So angle 10 is 100. What about 7? Angle 10, angle 7. Angle 10 is 100, right here. What's angle 7? Well, angle 7 is right here. Notice that's acute. This is obtuse. If they're not equal, they're supplementary. So 100 plus what is 180? That's 80 degrees. So what is their name? Well, they're on the same side and they're interior angles, so they are same side interior angles. And the relationship is supplementary. And last one here, 5 is 42. What about 7? So angle 5 is 42. What about 7? Well, what kind of angles are those? Vertical. So they are the same. 42 degrees, they are congruent, and they are vertical angles. That's it.